Obviously, in the real world, problems are a little bit more complicated than our bake sale example. And lucky for us, there are programs out there to help us solve these types of problems. In this video, I'll walk you through using Excel to solve linear programming type problems. If you haven't already done so, please make sure that you have correctly installed the free Solver Excel add-on. This Excel demo will be based on the following example, which is the same as the last scenario, except now you can also sell fudge, which has the following recipe: 2 sticks of butter, 1 cup of sugar, and 2 cups of chocolate chips. You can also sell these at $1.50, and each batch makes 30 squares. Once again, our question is, how many batches of each type of cookies should you make in order to optimize your potential revenue? Here, I've already constructed our updated mathematical model, which is the same as our previous one, except for a few changes. We now have a new decision variable to include in our objective function with a coefficient of 45, because we're making a batch of 30 and selling each for $1.50. And with the addition of a new recipe, we need to make the following changes to our constraints. Here we have our general Excel setup for solving these types of problems. The blue cells are those that will generate our optimal value. The orange cells are those that we will be needing to insert an Excel function into. And all the clear cells are those that are given to us in the problem. So let's take a look. Here I have listed out my decision variables, and above them are their coefficients that were given to us in the problem with their respective calculations. The blue area is where our optimal values will be generated. In the meantime though, I recommend putting in placeholder numbers to help you set up the Excel sheet. Here in orange, we have our objective function, and in this case, it's for solving 1 batch of chocolate chip cookies, 2 batches of sugar cookies, and 3 batches of fudge squares. And below we have our constraints listed with their coefficients. For example, 2 sticks of butters for chocolate chip cookies, 2 for sugar cookies, and 2 for fudges. In these orange cells, we'll be solving for each of the constraints. And then finally, in the right-hand side area, we will be including the perimeter of each constraint. Once this is all set up, you're ready to use Excel to solve the problem. To get to the solver, you simply go to Tools and then select Solver, which would then get you the Solver Parameter window. Here, we see where we will be putting our objective function and whether or not we're trying to maximize it or minimize it, the location of our decision variable cells, and here is where we list our cells that will contain our constraints. Most importantly though, make sure of 2 things. Number 1, make sure that unconstrained variables non-negative box is checked. Number 2, make sure you're using the Simplex LP method to solve these problems. Later on, if your Excel reports don't look like the ones of my examples, go back to this window and make sure that you have these selected appropriately. Alright, let's see this in action.